6.3 Linear Functions. Key vocabulary is a linear function, which is a function whose graph is a non-vertical line. It can be written in the form y equals mx plus b. That's your slope-intercept form, where m is your slope and b is your y-intercept. So example 1, writing a linear function using write a linear function using a graph. So letter A says use the graph to write a linear function that relates y to x. So all that is asking is for us to write this as y equals mx plus b. So when it says relates y to x, again, y equals mx plus b. So step number 1, we need to find the slope. So that means I'm going to use my slope formula, where m equals y2 minus y1 divided by x2 minus x1. You can pick whatever 2 points that you want. I'm going to pick 2, 0, and 4, 3. So I'm going to take 3 minus 0 divided by 4 minus 2. 3 minus 0 gives me 3, divided by 4 minus 2 is 2. So there's my slope, 3/2. Then I want to find the y-intercept. That's my b. So where it hits on the graph on the y-axis. So it is located at 0, 3. So that means that b equals 3. So if I have the equation y equals mx plus b, and I know my slope is 3/2, and I know my y-intercept is 3, I can plug it in to the respective letters. So this becomes y equals 3/2 x plus 3. Example 2, writing a linear function using a table. Well, just like we did before, we need to find the slope. So you can use the slope formula m equals y2 minus y1 divided by x2 minus x1. And you can pick whichever values you want. So I'm going to take the ordered pair of 0, 3 and negative 1, 5. So 5 minus 3 divided by negative 1 minus 0. Numerator becomes a 2, denominator is negative 1. So my slope is negative 2. My y-intercept is where my x is 0. So this means that my b value is 3. So when I have y equals mx plus b, and I know that my slope is negative 2, and my y-intercept b is 3, that becomes y equals negative 2x plus 3. Now, if you wanted, you could have also done inside the table, figured out the slope based off of that. So my y's are decreasing by 2 each time, as my x's are increasing by 1 each time. So if you do the change in y divided by the change in x, that's negative 2 divided by 1, which is negative 2. That's another way of making your slope. So on your own, we're going to use the graph or table to write a linear function that relates y to x. Again, just a fancy way of saying put it in slope-intercept form. Y equals mx plus b. All right, so I want to identify the slope. So I'm going to pick 2 of the ordered pairs. Well, I'm going to go with 0, negative 1, and negative 2, 0. So my slope is going to be y2 minus y1 divided by x2 minus x1. So that's 0 minus negative 1 divided by negative 2 minus 0. In the numerator, add the opposite. I have 1 divided by negative 2. So my slope is negative 1/2. Then my y-intercept, I want to see the point that hits on the graph at the y-axis, which is at 0, negative 1. So that just means my b value is negative 1. So y equals mx plus b. When I know my slope is negative 1/2 and my y-intercept's negative 1, this becomes y equals negative 1/2 x minus b. I'm sorry, minus 1. All right, letter D. To find my slope, I'm going to take the points 1, 2, and 0, 2, and do 2 minus 2 divided by 0 minus 1. 2 minus 2 is 0 divided by 1, well, that's 0. So that means my slope equals 0. Then for my y-intercept, I want to have my x value be 0. My corresponding y value is 2, so that means b equals 2. Y equals mx plus b. We have m equals 0, b equals 2. Y equals 0x plus 2. Well, 0x is just going to equal 0 plus 2. 0 plus 2 is 2. So y equals 2 for letter D. Example 3, we have a real-life application. You're controlling an unmanned aerial vehicle, a UAV, for surveillance. The table shows the height y in thousands of feet of the UAV, x minutes after you start its descent from cruising altitude. We're going to write a linear function that relates y to x. Again, that just means put in slope-intercept form, y equals mx plus b. And then we are going to interpret the slope in the y-intercept. So first, let's find the slope. So I'm going to take the ordered pair 0, 65 and 10, 60. So 60 minus 65 divided by 10 minus 0. 60 minus 65 is negative 5, divided by 10 minus 0 is 10. Well, I can reduce this negative 5/10 to negative 1/2, which is my slope. Then my y-intercept is where it is 0 for my x value. So that means my y-intercept is at 65. So if I take y equals mx plus b, and I know my slope is negative 1/2, and my y-intercept is 65, that gives me y equals negative 1/2 x plus 65. So we're going to graph the linear function, but not quite yet, because we need to go back and we need to interpret the slope and the y-intercept. So instead of just saying the slope is negative 1/2 and the y-intercept 65, the slope of negative 1/2 means the UAV is descending (1,000 feet per minute). And then the y-intercept of 65 means the UAV started at 65,000 feet in the air. Now, in case anyone is wondering why or how I knew that it is 65,000, it states over in the table that the height is in thousands of feet. So now we're going to go in and we're going to go ahead and, excuse me, we're going to graph it. So my x value is in minutes. My y value is in height. So for minutes, I'm going to start at 0. And then each line is going to go by 5. 5, 10, 15, 20, 25, 30, 35, 40. Now, if you do look, I went and I only labeled every other line just so it didn't get too crowded. Then for the height, I want to go all the way up to 65. So I could go by tens if I wanted, but I'm actually going to do that little line break that kind of looks like a heartbeat. And I'm going to start at, let's go with 45. Then 50, 55, 60, 65, 70, 75. Okay, let's graph this. So I'm going to start at 0, 65, 10, 60, 20, 55, 30, 50. Now, if I continue with this pattern, it would be 40, 45. So then I take my line and I extend it. Oh. So find the height of the UAV when you stop the descent after 1 hour. Well, in order to do that, I need to take my equation, which I had was y equals negative 1/2 x plus 65. I got that from my previous problem, located right here. So after 1 hour, well, 1 hour I need to convert to minutes. That is 60 minutes. So that's going to be representing our x. So y equals negative 1/2 times 60 plus 65. Y equals negative 1/2 times, oh, whoops. Half of 60 is 30. Positive times a negative times a positive is a negative. So y equals negative 30 plus 65. Well, negative 30 plus 65 gives me a positive 35. So what is the height? It is 35,000 feet. So comparing linear functions. The earnings, Y, in dollars of a nighttime employee working X hours are represented by the linear function Y equals 7.5x plus 30. The table shows the earnings of a daytime employee. So which employee has a higher hourly wage? Well, in case you missed it, there are two different people. There is the nighttime employee, who is represented with Y equals 7.5x plus 30. Then you have the daytime employee that is represented with the table. So in order to be able to see who has a higher hourly wage, we need to identify the slope in both of them. Well, it does tell us for the, oh, whoops. It does tell us the hourly wage for the nighttime employee. So the nighttime employee is getting 7.5, so $7.50 per hour. And we know that based off of the 7.5 attached to that X. And then for the daytime employee, we know that our slope equals 12.5 divided by 1, which is 12.5. So then this is $12.50 for the daytime employee. So which employee has that higher hourly wage? It's going to be the daytime employee at $12.50 per hour. So we're going to write a linear function that relates the daytime employee's earnings to the number of hours worked. So let's start with that. So that's going to be y equals 12.50x plus, well, if I were to start and make this into a 0, I would subtract by 1250 because I subtracted by 1. That gives me 0, 0. So that's my origin. So my y-intercept is 0. So the daytime employee's equation is y equals 1250x. So there's the linear function that relates the daytime employees to the number of hours worked. In the same coordinate plane, we're going to graph both of these to represent the earnings of two employees. Then we're going to interpret what it means. So my x-axis, I'm going to make hours. My y-axis is I'm going to make earnings in dollars. So the hours, I'm going to go by 1. So 0, 1, 2, 3, 4, 5, 6, 7. And then I want to go up to at least 50 because that is shown in my table. So I'm going to do my line break again. I'm going to start at the number 20. So again, that line break indicates numbers 0 through 20. I'm sorry, 0 through 19. So 20, 25, 30, 35, 40, 45, 50, and then it would be 55. So I'm increasing by 5s. So first I'm going to graph 1, 1250. So 1, 1250. Actually, I'm going to start with 225. So $2, 2 hours is $25. Then I'm going to go to 4 hours is 50, just because those actually hit on the graph. And then I'm going to create my line. That goes through my 2 points. All right, so now I'm going to graph my other. And I should label this one as the daytime employee. All right, for the nighttime employee, they start at $30. Then from there, after 2 hours, they have earned $25 more. So that's at 245. I'm going to draw my line. So that is going to be the nighttime employee. So when I interpret the graphs, that means we're going to explain what we're seeing. So I'm saying the daytime employee is earning at a faster rate. Now I know that the daytime employee is earning at a faster rate because this line is steeper. The nighttime employee starts off with a higher amount, which is 30.